Design and analytical calculations of double wishbone for Formula Student race car. The functional objective of the suspension system is to provide relative motion between the sprung and the unsprung mass. This is achieved by a spring to absorb the shocks and some kinematic linkages holding them together with particular degrees of freedom. Further, for better handling the kinematics of the system is designed and optimized. This research focuses on the simulation, design, and analytical calculations of the kinematical linkage called ARM. The double wishbone suspension geometry was analyzed in Lotus Shark software to procure the most appropriate location of the hardpoints. ARM was modeled in CATIA V5, Autodesk Fusion 360, and analyzed in ANSYS 16.0. Software results are correlated with the analytical calculations to obtain a feasible solution. Keywords: double wishbone, ARM, thickness calculation, rod end selection, vehicle dynamics, threaded joints, etc. Introduction. The FS car's suspension controls the angle, position, and velocity of each wheel to maintain a high value of mechanical grip while transmitting the forces generated by tires to the chassis. A reliable method to determine the forces produced by the road loads and suspension members opted. In this paper, a detailed analytical calculation was explained for deciding the A-arm diameter using a set of calculations. The component is designed to be cost-effective, durable, and lightweight. As the double wishbone undergoes tension and compression forces, the yield and buckling need to be calculated, followed by the threaded joints calculation for the rod ends as the force being transmitted through these to the chassis. Double wishbone. 2. Problem statement. The double wishbone suspension system is independent. This design allows the race car engineers to control the wheel's motion throughout suspension travel, controlling the parameters such as camber angle, caster angle, toe, roll center height, and scrub radius. They are a force transmitting and kinematic part, so dynamic stability is the most crucial factor. Designing by using lightweight material along with it being cost-efficient is the recent discovery many teams are trying to develop. In the era of upgrading trends, many teams are trying to evolve in a world full of research related to advanced materials. In this fast-changing and technologically developed world, there is much advanced software in use, but all that software is programmed on the necessary calculations. To correlate those results with calculations and further substantiate those software results, we need analytical calculation. Because sometimes that software is constrained to some limits. The paper explains the method to find the thickness of the A-arm by pen and paper calculation. These calculations require critical skill, and also, they are an essential set for sound stress engineers in the automobile industry. Some teams want better design irrespective of cost, and some want a mediocre design with the economical product. But many teams are trying to get the intermediate between them, so to improve this, we need our work to be well developed from all angles and aspects. Hence analytical form is considered to be more cogent. Suspension assembly. Objectives. 1. A lot of forces during cornering, acceleration, and bump are applied directly during dynamic conditions, so it is essential to produce a compact, lightweight, and reliable suspension system to increase vehicle performance. 2. To reduce the unsprung mass. 3. Combining analytical calculations result with FIA as it provides a good starting point for the design. 4. To understand how much an advantage FIA gives during the design process, it's first necessary to understand how analysis and design optimization are performed without FIA. 5. To determine loads, restraints, and material properties, pen and paper calculations played a vital role. 6. The FIA results verification and validation with an independent set of calculations are crucial to provide confidence in the analysis results. 6. Design philosophy. Choosing suspension geometries and components involves a wide range of choices and compromises. An analysis of the tire, suspension component, chassis, and road interaction is required to decide the trade-offs that will result in an optimum configuration for the type of vehicle. The necessary steps in designing a vehicle's suspension are: selection of the suspension type to be employed, selection of the wheels, establish the vehicle's dimensions, wheelbase and track width, model the suspension geometry, designing components. 7. Load transfer. The inertia of a mass is its resistance to change its state. For the change of state of a body, it must experience acceleration in its motion direction. Acceleration, braking, or cornering is nothing but the change of state of the vehicle, which offers resistance for a while and results in load transfer in a direction opposite to the force causing the change. No doubt, this load transfer persists for a short duration of time, but its impact on the car's performance is much more crucial.